Now, by adding the losses of our motor, let's see the first proof method of the magnetic energy released, albeit slightly, in permanent magnets. For this, we need to find the total power or energy released. First, let's find the coil heat losses. First, the ends connected to the two stators of the motor, where we will measure the coil heat losses, are idle. When we measured the resistance with a milliometer operating with a margin of accuracy of 2 in 1000, we found S1 value of 0.259 for the first stator and 0.269 for the second stator, respectively. During the measurements, the current seen in the first stator on the power meter was 2.42 amperes. And the square of this value, which is 2.42 squared, is equal to the coil resistance, which is 0.259. We found the value of 1.51 with the formula current squared times R. The current in the second stator was 2.42, and with the same calculation, we can see that 1.57 watts of power was consumed for coil heat losses. Although it is in our favor here, we did not calculate the additional coil heat losses that increase with temperature increase and skin effect in order to avoid complex calculations. Yes, we have seen that 3008 watts of power was consumed for total coil heat losses. Now let's find the mechanical losses. Let's leave the connection input cables of our main motor connected to the dynamic torque meter idle. Let's give different voltages to our second auxiliary motor and try to find the same RPM speed, i.e. 1108 RPM, as during the efficiency calculation above, that is, when rotating clockwise. I have seen from the vehicle a power of 3.9 watts at 1106 RPM. 1107 RPM and 4 watts for mechanical power at 1108 RPM. We have seen that a total of 4 watts of power is spent for friction, wind and vibration losses, that is, for mechanical losses. Now let's try to find the total power obtained. Net mechanical power is 98.3, coil heat losses are 3.08 watts, and mechanical losses are 4 watts. A total of 105.38 watts of power is obtained. As we saw, the total electrical power we spent was 103.55. When we divide the total power obtained by the electrical power we spent, we can find the value of 101.7. Here we find a positive value of 1.7%, and we can see that 1.7% of energy is adding to the system from the permanent magnets. The same amount of energy is lost in the magnets' pathways that create magnetic energy. I will also try to eliminate the question marks about the existence of magnetic energy obtained from the magnets in the heads by sharing a second method in the following videos, which I found later, an easier method that anyone with intermediate electronics knowledge can do at home with an oscilloscope and coil magnet arrangement. The blog page containing sections and details from the article I prepared on this subject can be accessed from the link I will write in the comments. I invite everyone to work together to confirm the measurements and move the studies forward. Thank you for listening and your patience.